You look like you haven't have enough diffing information, so the next talk also will be related to kind of pairing, diffing, and merging of documents, and this talk will be by Robin and Nigel from DeltaXML.
Thank you. I'm Robin Fontaine. I'll be doing the first part of the presentation, and my colleague and co-author, Nigel, will be doing the second half. So, merge and graft, two twins that need to grow apart, is the title. And the context of what we're talking about is version control systems, which I'm sure most of you are familiar with. For example, Git. And increasingly, there is more and more XML and JSON data in these systems. And a key part of any version control system is the ability to branch things, make modifications, and then merge things back together again. And we all know the limitations of line-based algorithms, merge algorithms, and diff algorithms, indeed, for structured data like XML and JSON. So we should be able to do better. That is the intention of what we're talking about today. Because anybody who's done a merge in one of these systems knows the pain of having tens or even hundreds of conflicts that you have to then go through manually and sort out. It's very tedious work, but it requires a lot of concentration, and it requires also quite a high level of expertise. So clearly, in the XML world, in the XML domain, we should be able to do better, because we've got structured information, we've got XPath, we've got XSLT. We should be able to do much better. So our intention is to make life easier for users of these systems. Fewer conflicts, better merging, sorting things out, if we can, by rule-based processing. And what we want to show today is that particularly we're focusing on merging and grafting, and I'll show you that those are slightly different ways of doing things, and at the moment they tend to be treated the same in the Git system. So there is scope for improvement there. Let me just start off by mentioning a talk that Nigel and another colleague, Tejas, did last year at XMLPrague. And that was talking about two different types of merge, concurrent merge and sequential merge. So in concurrent merge, you've got a common ancestor, and then you've got two derivatives of that ancestor, and you want to merge those together. So the changes in this branch and the changes in that branch, you want to merge together to produce a new version. So that's concurrent merge, and sequential merge, quite different. You've got a series of versions of a document. I've passed it to somebody else, and they've passed it to somebody else and made edits, and you want to look at the history of changes throughout that document, throughout the time span of that document. So that's sequential merge. So two different types of merge. Today, we're really talking in this concurrent merge area and exploring that a little bit further. Now, I'm sure you've all been walking on hills, and you see a hill, and you say, well, I'll just walk to the top of that hill. And when you get to the top of that hill, lo and behold, that isn't the top. There's another one just beyond it. And it feels a little bit like that with merge, that you climb the merge hill, you discover, no, there's a concurrent merge and there's a sequential merge, and you climb the concurrent merge hill and you discover, no, there's graft as well, and you climb that hill and you find there's some more stuff up there that there is to explore. So we are very much, I think, on a journey here, exploring and improving things and learning things as we go. But the XML technology stack, and XSLT and XPath, gives us the opportunity to do that, because we've got a way of representing multiple documents in one. We've got a way in XPath and XSLT of applying rules so that we can create derivatives of the merged document. So it's an interesting area, and it's an area I think that we in the XML community are well placed to explore. So let's look at merge and graft. Graft is often referred to as cherry pick as well, particularly in the Git world. Merge, first of all, we've got some common ancestor and various versions of that have been produced by modifications. And then we've taken a branch from that and modified between Q0 and P1, and then modified that again and we end up with a Q2 version and P2 version. The classic merge is saying, right, take the common ancestor, merge those changes together to produce a new version of Q3. Cherry pick is slightly different. That's saying, I don't want to merge all the changes, I want to merge just some of the changes. So I want to merge, in this case, the changes between P1 and P2 into Q2 to produce a new version Q3. So it's not quite the same thing, and it's very useful in the sense that you've got two perhaps different versions of a product, and you get halfway through the development of that, and you do a bug fix in one of those sides, and you want to just move the bug fix across, but nothing else. So that's why you would want to use the graft or the cherry pick. So the question is, can we implement that graft as a merge? In other words, can we just change the ancestor? Here we have the ancestor Q0. Can we just change the ancestor to P1 and create the same result? So let's look at it and see whether that works or not. So I've got an example here. It's in JSON, but we've seen a lot of JSON today, and JSON XML are very similar. This is just a simpler way of doing it. This is a very simple example. When you get to tree-structured stuff, obviously, life gets a lot more complicated. But this is just complicated enough to show you what I'm trying to explain. So we've got here, we've got P1 and P2, and whoops, going a little bit too fast there. P1 and P2, and we've got Q2. We're trying to merge or graft the changes between P1 and P2 into Q2. So these are the changes here highlighted in P2. John has been deleted. Mike has had a version update. There may be a lot of data associated with Mike, but we've just shown it here as a V1 and V2 just to illustrate a change. And similarly, David has been updated. And here's Q2. So what happens then with a graft? First of all, John has been deleted. Well, that's no problem. We can delete John. There's no difficulty with that. Mike has been updated. That's fine. We can update Mike. No problem. Anna, no changes to Anna at all. So Anna remains as she was in the previous version. David has been changed, but doesn't appear in Q2. Well, that's not a problem. I've got a change that doesn't apply to my data set, so I can ignore that. And then Jane is there in Q2, but not in P1 to P2, so again, no problem. There can't be any change associated with that. So that's graft. So that's what we're trying to achieve. That seems intuitively what we want when we do that cherry pick. So what happens if we do a merge? Merge is much more symmetrical than graft. So here we've got the changes that we saw before between P1 and P2, but we're also considering the changes between P1 and Q2. So now we've got a bit of a problem because John's been deleted in P2, but changed, apparently, in Q2. So that's a conflict. We don't know what we can do with that. And similarly, we have another conflict down here with David because David has been changed here and apparently deleted in Q1. So we get a conflict. So we have a situation here where merge is not giving us quite the results that we wanted if we were just trying to do a graft. Now, one of the common ways of resolving these conflicts is to say, okay, I'll choose my data or I'll choose their data, and that will override. So first question we need to ask is, well, would that work in this situation? And no, again, it doesn't quite work because we still don't get exactly the results that we want. So taking the Q2 priority, or indeed taking the other priority, doesn't work. And let me just show you those three things together so that you can see that the results are a little bit different. So graft is not quite the same as merge, although it does tend to be implemented that way in Git and indeed in other systems. So where are we then? We've got better merge tools for XML and JSON if we can take account of the structure and not just use the line-based systems. But the merge and the graft are not the same, so have the opportunity of distinguishing between them and having in our Git system the ability to do those things in a different way. But, as Nigel will move on to explain, Git doesn't quite see it that way. It doesn't make that distinction. So can we perhaps either force it to make that distinction, or can we, in some way, improve the situation for XML and JSON within the Git scenario? So I'll hand over to Nigel to talk a little bit more about the detail of how we have experimented in that area. So over to you, Nigel.
Hello, everyone. Good afternoon. One of the review comments we had for the paper asked us to take a kind of more practical look at how Git and Merge, how Merge and Graft would work in Git. So what I'm going to show you is some experimental work that's in progress. So there's, sorry. What I'm going to show you. Okay. What I'm going to try and show you is some experimental work that's in progress, and we're trying to use that to show a practical application of how Merge and Graft will work in Git. So I'm going to concentrate on some of the practicalities now and show you some work we've been doing. This may or may not end up in products, and very much experimental work at the moment. So I'll quickly address why we're talking about Git and why we're thinking of Git. So this is the last year's Stack Overflow developer survey, and one of the things you'll notice is Git is by far the biggest leader in source code version control. So I think this survey is kind of addressing the area of source code. We're also seeing Git used for both documents and some forms of data. Configuration data is something that we're seeing. So we disagree slightly with Sebastian's take earlier. We do see that Merge is used for some forms of data. And so we heard earlier yesterday, for example, of Git being used for data. So it is different forms of both. It's moved from the code world into the world of documentation and of data. A few years ago, that looked completely different, and it was Subversion about 7 or 8 years ago was the market leader, and Mercurial and Git were kind of the second ones. So what I'd like to look at is how a merge works inside Git. So look at the kind of Git architecture that's used here, and talk a little bit about two common patterns we've identified on how you can integrate and improve the way Git merge works. So when you do a Git merge operation, you will look at the documentation and you'll see mention of a strategy or a scenario, and that is the first part of the process. What it's trying to do is analyze all of the files in a given commit, look at the directory structure, understand renaming operations, understanding moves, and providing triples of files that are then passed to the merge driver. And it's the merge driver that's the actual underlying tree alignment algorithm that's used in Git. And a number of you may have heard of something called diff-free, and that is what Git uses. It's usable as a command line program, and it takes 3 inputs, the ancestor, 2 branches, tries to merge them together, and will report conflicts and deal with non-conflicting changes as well. So the 2 patterns we've seen and identified are one where the driver will produce a result, and that result is typically a file with textual line markers, and these have got angle brackets in them, but they tend to be 7 angle brackets in rows, equals signs, and another angle bracket, and those kind of differentiate the conflicting lines. I will show you one of those later. And what happens in the first kind of scenario workflow we've identified is that these then used by the merge tool directly. And so you can use a merge tool such as Visual Studio Code or tkdiff, and they will automate the processing of those line-based markers. Like a number of you, are probably also taken those line-based markers and tried to resolve them in a text editor, and then say, this file has been resolved, I've done my resolving, hand it back to Git. So that is one way. Another common workflow we see is the merge algorithm exists in the driver, but is also re-implemented in the merge tool. And I want to talk about that model a little bit more. So I've tried to use the letter M to indicate where the merge algorithm happens. And so you can implement it in the driver, but the merge tool has access to the original input files, so it's at liberty to re-implement a merge and do it again. And perhaps it does that because it needs better data structures than it can get out of the textual representation. But that is a common pattern we see in a number of merge tools as well. And so in order to explore this a little bit more, I'd like to consider two examples of a textual merge. So this is a fairly simple example, and it shows the top line is the ancestor version, 2 versions below that, and all that's happened is attribute order has been swapped. And if you run that if you do a git merge on that, you will find you get a conflict. The built-in textual diff-free-based algorithm will give you a result as shown at the bottom. And that's what it was intended to do. However, if what you're doing is you are using the textual-based merge driver on the bottom, and you then pass that to a merge tool that understands that as XML, you can get a confusing situation for the user, in that the user, when this arrives at the merge driver will signal as a conflict, and that will then cause the merge tool to be invoked. If that merge tool is XML aware, it might not show you that. It might show you no conflict. It might show you a good result. So that kind of situation, discrepancies in the conflicts between merge tools that understand the XML format and a driver that understands it as text, can cause difficulties to users. I'd like to look at another example. So this is an example of a configuration file. It's actually the configuration file for our firewall. I've changed the IP addresses. But what this shows is that you can do a merge with the line-based textual algorithm, and you can get a bad result. So this is not a well-formed XML result. You've got 2 protocol 6s appearing in the result at the bottom. But it's non-conflicting. And if you use a textual driver for this, you wouldn't invoke a merge tool to handle that any better later on. So this is another reason why we believe that the merge driver is a good place to improve the intelligence of the merge operation, as well as the merge tool. So how does a merge driver work in Git? If you've used a merge tool, you'll be familiar with the git config process. And so you use the git config command, and you can configure one or more merge drivers. You give the absolute path to the driver. And you can also specify a set of patterns, and so you could use that to say which drivers get used for which type of file. And so you could say, I'll use an XML-specific merge process for XML, XSL, XSD, and you could also do the similar kind of thing for JSON. So that's how you configure a driver. Now, I imagine most of you are familiar with using Git. I suspect I don't need to go into a lot of detail. And there's no big surprises here. What I'm trying to show you is how we've configured the driver and how the Git process works in something like ASCII source tree. The interesting bit comes at the end when we show the handoff to the merge tool. So the basics here are you're on a branch. It's highlighted as branch A. I know that doesn't read too brilliantly. And then you're trying to merge. You select another branch, which is B. You click the OK button. And you will get information about conflicts. And you get the same kind of thing on the command line if you invoke Git on the command line. We've added a few debug messages here. But essentially what it's saying is that a number of files in that merge were conflicting. And then source tree will give you a dialog to show that there are conflicts, you need to deal with them. And it even points you to the right place in the menu for how to do that. And if you launch an external merge tool in Confluence, you can do that. So the conflicts here are shown with a orange triangle with the exclamation mark. If you ran a git status on the command line, you'd see the C, capital C mark at the start of the line. And so what you've now got to do is deal with the conflicts, and this is where the merge tool comes in. It's meant to try and automate and speed up the handling of those conflicts. So I'm going to show you some experimental work we've done with Visual Studio Code. And what we've done here is we have used our tree-based algorithms, but to analyze and align the data, identify the conflicts. When we've identified the conflicts, we've actually used the textual markers that the difftree algorithm uses to show the changes in as fine a granularity as possible. And we can then process that with Visual Studio Code. So you can see just above the turquoise green line on the first edit, there's a few things you can click on. So accept current change, accept incoming change, accept both. It's an editor, so you can accept both of them and customize it as you need it. And so that is a way of automating the conflict processing in a merge tool. This is currently available in Visual Studio Code. So all we've done is integrated it into source tree. You then have to close the tab or close the Visual Studio Code window, and that signals back that the merge tool has resolved that conflict, and source tree will probably change its little icon when you do that. So it's an experiment. We've realized the limitations in this approach. We have a conflict between the granularity in which we're trying to describe the changes and the ability to reformat the content so that when you do the accept and accept one of the other branches, you still get a valid result. So it's a bit of a compromise, but we kind of are beginning to look at alternative ways of doing this. So we're interested in exploring the idea of seeing what we could improve on this format and see where we can take this to improve our results. So quickly look at our conclusions. So we see the benefit of putting better intelligence into the merge process, and we believe we can get fewer conflicts. We're beginning to measure that, so we've got experiments in place where we can replay lots of merges and measure, improve this. And we believe that the merge algorithms are best done in the merge driver, but it could also be done in the merge tool, or we believe that we can improve the formatting. So Robin has argued that the merge and graft cherry pick are arguably not the same, but they're treated in the same way in Git, and we're seeing that as a problem. We haven't yet found a way in the merge driver to know if we are doing a merge or a cherry pick. And if anybody knows a solution to that problem, I'd love to hear about it. Communication, and so we've realized the limitations of our kind of line-based approach of that experiment I've shown you, and would like to look at how we can improve on the communication between the merge tool and the merge driver, if that's appropriate. And we realize that textual line-based format has been around at least 20 years from my memory. Other people might know its origins more, but we think we can handle conflict in tree-based format using a tree-based representation, and we believe that's the way forward, and would be happy to talk to anybody who wants to work in that area or who wants to look at this problem. Thank you.
Thank you very much, and indeed we have time for questions. over there. And then George.
So a quick one. Can you merge spreadsheets?
Can you merge spreadsheets? We're definitely working on that. Yeah, the spreadsheets are rather like tabular data, and tables, CALS tables, HTML tables, etc., have been, I won't say the bane of our life, but we've put an awful lot of effort into trying to make both comparison and merge of tables much better. And a lot of what we've done there, I think, would apply to spreadsheets. I think one of the difficulties is that if the rows can be in a different order in the two documents and the columns can be in a different order in two documents, then you've got a sort of 10,000-piece puzzle that you've got to put together in some way, and it's not a trivial business. But in principle, yes, you have shown that you can represent spreadsheet information in XML. So if we were good enough, we should be able to compare that. I suppose my question back to you is, well, what are you going to do with the differences when you get them? How do you want to use them? But yes, work in progress, I think. It's not a trivial problem, as you well know.
And then from a Git perspective, that should be a separate kind of merge driver that could be used in Git.
Okay, then there is a question from George.
George Mina from Oxygen. So when you represented that graphic with the cherry pick, can you go back maybe to that slide? My assumption about merge is that you have, a common ancestor and then two revisions. But there you can clearly see that P1 is not a common ancestor. So that is, of course, the merge will not work probably in that case because P1 is not a common ancestor for Q3 and P2, right? So maybe that's basically why the merge does not work in this case that you presented, right? Because you move the assumption, you do not have the common ancestor. You have P1 is not Q0 should be the common ancestor, right?
Yes. Let me attempt to answer that, and then Nigel can as well. Yes, part of doing this is finding the correct common ancestor. That is certainly a part of it. But I think what I've been arguing is that actually those are slightly different processes because the merge is almost by definition a symmetrical process, whereas Graft is not. You're trying to take changes between two and apply it to another one. It's not quite the same situation. You don't want quite the same results. So that's my put on it. I don't know, Nigel, have you got anything to add to that?
I would say that in that diagram, there may not, you've drawn an arrow between Q0 and P1. That arrow may not be there in a graph.
That is true. They are not. If I can, perhaps the example, I've changed this example slightly from what I've got in the paper here. But if you look at this, John here, you've got V2 there in P1, and you've got V1 here. So what has actually happened here is that the data has been changed between Q0 and P1, not between P1 and Q2. So where the change has happened, you don't know without actually having a fourth file in there to work out what's going on. So you could argue, I think, if you want to do this better, maybe it's a four-way merge rather than a three-way merge. But, as Nigel said, there may not be a common ancestor because these two pieces of data may be in some way independent and they never had a common ancestor. So you may not have the information that you want.
Yes. So the assumption of using merge for that fails from the start because you do not have the common ancestor.
Yes. Yeah, it's not the right way to do it. You're absolutely right, and therefore you need to do it a different way, and that is what we're saying.
Okay.
Yeah, there is one last question.
So especially on this slide with this merging, like P1 and P2 into Q3, I think another operation that you could use in this scenario would be git rebase. So would your tool be helpful in this situation in resolving conflicts during rebase, which seems what was happening when you described Graft? right? This was basically a rebase.
I don't see rebasing as the same as grafting. That's my personal take. I think they are different operations, and the graft is trying to pick changes between 2 points. I don't think the rebase is doing the same, is intended to do the same thing. But I think the...
If you could just go back to this slide with this free
Which one?
This one, yeah.
Yeah.
So like the picture in the middle, this is a rebase, right or not?
I don't know what rebase
I mean,
is.
it sounds natural to me, at least, you know. So I mean, it's just an idea. This would be very, very helpful if we could use it also during conflict resolution during rebases. It would be very, very useful.
Okay.
At least in some scenarios, I can think of some.
Yes, yeah, no. We have issues with the way Git works and how it does cherry picking. I'm quite happy to accept that you want to see improvements on the way rebase works, and you want the conflict representation, the conflict resolving there too. I think that's perfectly valid request. The problem we're seeing is that we don't know how to implement this because the merge driver mechanism is passing us data. We can't differentiate between a merge and a cherry pick at the moment. I must admit I haven't studied what happens with a rebase and the information a merge driver will get even if the merge driver is invoked. I suspect not.
But I think for us in the XML community and with Jason, I think the potential is really quite interesting here because, yes, you want a rebase which may be different from a graft, which may be different from a merge, and we should be able to cater for all of those because we've got XPath, we've got XSLT, we can apply rules, etc. And not only that, but you can also apply different rules throughout your XML tree. So you might say, well, if I'm merging Maven files, for example, and I get a conflict with versions, well, I'll take the highest version, and I'll resolve my conflict automatically that way. And that, again, is much simpler to do when you've got the tools and the technology stack that we've got. So I think the future in this area is quite exciting to be able to make life a lot easier and make the results a lot better than we've got at the moment.
Yeah, of course. Thank you.
Okay, thank you very much again.
Thank you.